Super Calculus. In this video, we are doing section 5.2, which is basically the same thing we've been doing. It's proving trig identities, but they're just going to get harder. So here is an example. In this video, I'm just going to do examples because practice and I think narrating the thought process is going to be helpful. So for this example, we're going to prove cosecant squared of x minus 1 divided by cosecant squared of x equals cosine squared of x. So for this one, I'm going to start, and right off the back, I see things being squared, and this one has a minus 1, so that makes me think Pythagorean identity. And sure enough, we can use the Pythagorean identity to change this to be cotangent squared of x. And the reason for that, like I just said, is Pythagorean identity. Okay. So now I am going to change cosecant. So this is 1 over cosecant. And I'm going to change 1 over cosecant squared of x to be sine squared of x instead. And the reason for that is the reciprocal identity. And my thought process is, right, like we don't want a 1 in here, goal is to get to cosine, so that's why I want to try to change the numerator. I don't want a fraction, so I'm going to get rid of the fraction by using a reciprocal identity. Now we're at the point where I don't want cotangent, right, I'm trying to get to cosine squared. So I'm going to change cotangent to be cosine squared over sine squared. And then these two, well, first of all, the reason, right? That's the quotient identity. And then sine squared over sine squared cancels, and I'm going to be left with cosine squared, which is good because that's what we wanted. And that was just simplification, which is algebra. And there we are, we're done. So let's do another example. Let's do secant of x times cosecant of x times tangent of x minus 1 equals tangent squared of x. We're going to start with the left side. So there's a lot going on right here. I'm going to start with changing secant and cosecant using the reciprocal identity. So like I said, just use the reciprocal. And now I'm going to change this to be sine over cosine. And that was the quotient identity. And then I'm going to just multiply these. So that's sine of x divided by cosine, or yeah. Right. And that was just algebra. Okay. And next I'm going to simplify, right? Sine will cancel. So I'm going to be left with 1 over cosine squared of x minus 1. I guess I could have simplified earlier, but you could have gone from here to here. I just didn't even notice. Okay. And now I don't want cosine squared, so I'm going to use the reciprocal function, because if I have a squared and a 1, then that is potentially going to be a Pythagorean identity. So let's try it. So 1 over cosine is the same as secant squared. And secant squared minus 1 is the same as tangent squared because of the Pythagorean identity. And that's all. So all of these problems is the same concept of just kind of messing around with it and using your identities to manipulate and simplify.